Okay, today we're going to go over some basic statistics. We're going to cover mean, median, mode, and range. So on the screen here, I have a couple of the formulas. Mean is the sum of the data values divided by the number of data values. Median is the middle of the sorted data, which we'll talk about in an example. Mode is the most frequent data value. And quick note, there can be no mode in the data or multiple modes. And the range is your maximum minus your minimum data value. All right, let's just get right into it. Number one, find the mean of the data set, 99, 36, 52, 23, 67, 97, and 9. Round your answer to the nearest tenth. So the easiest way to go about this is to just use a calculator. So I'm going to go ahead and use Desmos here. So I'm just going to copy those values into Desmos. All right, so 99 plus, actually before I do this, in Desmos, if you hit the slash key, it starts a fraction for you. So as you can see here, I have a numerator and denominator I can toggle between. So on the top here, I'm going to put the expression of me adding all my values. And let me scoot over the expression. Yeah, so I have 7 values here and there's 7 values there. So okay, good. And you divide by the number of data values, which is 7. So that's why I counted 7. And the answer is 54.7 rounded to the nearest tenth. We would take 54.7 to be correct. So 54.7. Number 2, find the mean of the data set. So basically same question, but let's go ahead and work with decimal values just to practice a little bit with your calculating skills here. 89.4 plus 79 plus 82.7 and that looks good. And I do have 8 values that I added. So on the bottom, I'm going to divide by 8 as my denominator. So 67.2 would be the correct response for that one. 67.2. Calculate the mean, median, mode, and range of the data set. Since we're talking about median, you do have to organize your data from least to greatest. So I'm going to go ahead and try that here. So I have my technique when I rewrite my data is I'll write the value that I think is the lowest, and then I just cross them out as I go so I don't repeat any data. So 24 is the lowest, and then 33, 45, 60, 65. We have another 65, and then 93. So that looks good. All right, so mean, same deal as before. Just hop on my calculator. And I'm going to go ahead and find the mean of this data. And there's 7 values, so divide by 7. So 55, 55, according to Desmos, my calculator, is the mean. Now the median is actually a really simple value. Sometimes it requires a little bit of calculation, but in this case we don't. If you notice, we have an actual middle of our values here, because on the left, if you kind of group up on the right and left the same amount of values, right? We have 3 values on the left, 3 values on the right. If we group up 3 on the left, 3 on the right like that, we have 1 value exactly in the middle, and that's our median, 60. Now the mode of your data is the value that appears the most frequent data value. And we have a pretty nice data set here where the most common value is 65. So the answer is 65 for that. And lastly, off to the side here, they want us to calculate the range. It's the maximum value in your data set minus your minimum value. So biggest minus smallest. So writing our data in order is really helpful here too, because our max is 93 and our minimum is 24. And whatever that equals will be our range value. So since I have a calculator open, why not? I have to calculate 93 minus 24. Just to make sure. 69. 93 minus 24. So there's how you calculate mean, median, mode, and range of a data set. Okay, so number 4, same deal. So I'm going to go ahead and rewrite my data. So I'll let you worry about the mean. I want to talk about what happens in this case because we have to do something a little different in this example. If we try to find the middle of our data, what you'll notice is if you kind of group up, let's say 4 on the left and 4 on the right, there's no middle value, right? There's 4 on the left, 4 on the right, but there's no room for a middle value. So there's no true middle, right? If you have an even number of data values, you don't have a middle value because there's kind of like 2 values competing for the middle, right? They're closest to the middle. Our middle should be right in between 3 and 5. So to calculate the median, if you don't have a central value, right, that middle value right in the middle of your data, you just find the average. So the average of those 2 values. So the 2 values that would compete for that middle value, the median value, you take the sum of them, and then you divide by 2, because it's the average of 2 values. You add them and divide by 2. So the median is interesting because the value is 4, but that value is not part of our data, but it is the median. So the reason why we need that is because the definition of the median is actually 50% of your data should be less than that, and 50% of your data should be greater than that. So it literally should divide your data in half. Half should be on the left, half should be on the right of your data. Okay, and then we talk about the mode. And here's what's interesting about the mode in this case. You notice that there's 2 1s. So you might think, okay, we found it, it's 1. But the problem is there's also 2 9s. So if there's any value in your data set that's repeated, it can be a potential mode. But if there's a tie for the most frequent data set, if there's a tie for the most frequent value, they can both be the mode. So the mode would be 1 and 9. So the mode would be 1 and 9. And if you notice in the directions, just so you can't type in 2 values into Canvas, it says to give the sum of the modes as your answer. So if 1 and 9 are the modes, then we would just put 10 here. That's just for the sake of the assignment. That's not what you would do with your modes. It's just so that it's easier to check the answer on my side of things. So if 1 and 9 are correct, 10 would be the answer I would want for the mode. So I'll leave the mean and range for you on that one. Should be pretty easy to calculate because we did that in the previous example. Okay, Quinton's test scores are 95, 90, and 83. What must he score in his next test to have an average test score of 90 on the 4 tests? So I'll give you a little hint here that average is the same as the mean. So this is like an average problem. We need to use our average formula, the mean formula. So the mean is you add all the data values and divide by the number of data values. So we're taking the mean of not 3 tests, but we have to include his next test. So the average we want is 90, right? We want the average to be 90. So I want the average to be 90, but the average is a calculation. It's the 3 tests that Quinn already took, 95 plus 90 plus 83. But then there's a mystery score, right? It says, what is the next score? So I'll say plus X. And then you divide by how many tests Quinn would have taken after this test, and that'd be 4. So this is an average equation, and we have to use some algebra to solve it. So to start solving it, I'm going to get rid of this 4. That's dividing the right side of the equation by multiplying by 4. 4's cancel. And we have 360. So in order to get an average of 90, we know that Quinn has to score 360 test points. And so far, this person has gotten a 95, 90, and 83. We just have to figure out what that last value is. All right, well, I don't really want to deal with all those values. So let me add them up on my calculator here. So a 95 plus a 90 plus an 83 is 268. If we subtract 268 on both sides, we would find that X equals 92. Quinn needs to score a 92, and then their average would be a 90. So the answer is 92. Number 6 is very similar, so I'll leave that one for you. Okay, number 7. The above representation is called a dot plot. Each dot represents a data value in the data set. How many total data values are represented in the dot plot? So kind of annoying, but you do have to count all the dots you see. So let's see here, 1, 2, 3. So this height is 6, and then we have 2 plus 3, so that makes 5. We got another 5 and another 5, so that makes 10 plus 2, 12. These two added would be 5. This is 7 plus 4, so 11. And then we just have one more, so 1. So the total data set includes 6 plus 5 plus 12 plus 5 plus 11 plus 1 data values. And hopefully I counted correctly, but I got 40. So that's how many total data values are represented. What is the mode? So this data is asking how many minutes does it take to eat breakfast. So the mode would be which time slot has the most frequent data value. So just basically look for the tallest set of data. So if you remember from before, I counted this as 6, so that's a lot. It doesn't seem like there's any others, except when you get to here, this one's 7. So since that has 7 data values, 10 is the mode amount of minutes it takes to eat breakfast, so 10. How many people take more than 10 minutes to eat breakfast, according to the dot plot? So remember, more than does not include 10. So more than 10, that's just this part of the data. So 5. 5 people are a little slower, and they take 11 or 12 minutes to eat their breakfast. All right, number 10, we introduce what's known as a histogram. Each bar represents a frequency of the data interval. For example, from this histogram, we know that 7 women aged 40 to 50 years old visited the library. So just to make sure you have some background information, if you're between 40 and 50 here, right, this little piece here, that lines up to 7, right? That's 7. Okay, how many women aged between 50 and 60 visited the library according to this histogram? Well, if you see here, let me erase this now. From 50 to 60, and I know my screen got a little blurred here, but that would line up to this data value, or this frequency, sorry. So that's in between 8 and 10, so that would line up to 9. So that bar that's holding all the women aged 50 to 60 holds 9 women. Okay, same histogram. How many women younger than 50 visited the library according to this histogram? So if you're younger than 50, then that would kind of group up all the data from here to here. So all the bars added below 50 are part of this answer. So remember the 40 to 50 was 7. So we got 7 here. And then if you can see here, 30 to 40, it lands in between 2 and 4, so that's 3. And then 20 to 30 lands between 0 and 2, which is 1. And then no one between 10 and 20. So 7 plus 3 plus 1, that would be 11 women. Number 12, the histogram above shows the efficiency level in miles per gallon of 110 cars. How many cars have an efficiency between 15 and 20 miles per gallon? So that would be between here and here. So whatever height that bar reaches on the frequency, that's the answer. So it lines up to 35. So 35 vehicles or 35 cars have an efficiency between 15 and 20 miles per gallon. How many cars have an efficiency of more than 20 miles per gallon? Well, that's starting here, and it goes all the way to the end of the histogram. So there's 2 bars that we're going to take the sum of here. So there's 25 cars in this green bar from 20 to 25, but then you also have to add the 25 to 30 bar, which holds 15 on the frequency. So 25 plus 15 is 40. Okay, and lastly, what percentage of cars have an efficiency of less than 20 miles per gallon? So to find a percentage, one way you can think about it is the part divided by the whole, or however many values you want divided by the total data set. So what percentage of cars have an efficiency of less than 20 miles per gallon? So less than 20 would be all the cars to the left of that red line. So this big the big blue bar here is 35 cars. The green bar next to it is 20. And the bar next to that is 15. So total number of cars in this data set, there are 110 cars. So that's our total. But the number of cars we're looking for is 35 plus 20 plus 15, which is 70. So if you see my hint there, it says divide the number of cars by the total number of cars and then multiply the result by 100, right? So when you divide, you get something called a decimal. And then to convert it to a percentage, you just multiply by 100. So just to double check, 35 plus 15 plus 20 is 70. So 70 out of 110 cars meet this requirement. And I just need to turn that into a percentage. So here I go. So 70 divided by 110. That's a decimal. And then you just multiply by 100 to make it a percentage. So 63.6. And it repeats forever. And we'll just go ahead and go to the tenths place. So 63.6. So 63.6% of the cars have an efficiency of less than 20 miles per hour. All right, so I hope that helps with looking for mean, median, mode, and range, and looking at different kinds of data representations.